All right. So we finished going over chapter 1, 2, or the homework for 1, 2. So now we're going to look at 1, 3. I'm not going to cover every little thing on 1, 3. There's a few things that, I guess they would be semi-important, but there's certain things that I'm going to skip just because I think they're things that are more important. I just don't want to get bogged down with a lot of things, okay? And that's kind of a little bit of this section right here. Let's just take a look at a couple things before we actually show you some stuff that I want you to write down. So this stuff right here, you don't have to write down. I do want to introduce you to this guy right here. His name is Euclid, page 10. Are you on page 10? His name is Euclid. He's a very important person. It says he was around 300 BC. That means 300 years before Christ was even born, okay? So 300 years before Christ was born. So he's like Old Testament kind of time, all right? He's not in the Bible or anything, but he's an actual person that existed, and he wrote down a lot of stuff. And a lot of the stuff, most of the stuff that's in our book right now is from this guy who lived 300 years before Christ. Can you imagine that? So his name was Euclid. He was Greek, and he was a mathematician. And a lot of times we call our geometry that we're studying right now, we call it Euclidean geometry. Why do we call it Euclidean geometry? Because it's from Euclid. That's right, this guy Euclid. So it's Euclidean geometry. Remember I said the word proof earlier? Is everybody listening to me now? Okay, Zion, that's enough. It looks great. Just put your hands down, and it's just... Stop the twirling. All right. Put your hands down. Okay. There you go. Now you're paying attention. See, when you're doing that other stuff, it's just distracting. There you go. All right. So there's another word. If you look in the third paragraph, do you see that where it says basic relationships? Everybody see that? You're in your book? All right. It says basic relationships that are assumed to... Okay. Shouldn't be any reason to talk. It says basic relationships that are assumed to be true without proof are called postulates. Sometimes they call them axioms. Okay, that's a word you're going to see all throughout the rest of the book, is the word postulate. And what is a postulate? It's just accepted as true. All right, you don't have to prove it. It's just true. Everybody got it? There are things we're going to do later on, and I don't think they mention them here, but they're called. Oh yeah, they do. In the next paragraph, there's a thing called theorems. There's a difference between a postulate and a theorem. Now, if you would read a postulate and you would read a theorem, they sound very similar to each other. It's kind of the same. But a theorem can be proven in a thing called a proof, which we're not going to do a whole lot of in here. Again, I used to really harp on this, and it used to be something I thought was very, very important. But right now, due to time, even though we are at the beginning of the year, I know we have a lot of stuff to cover, okay? So we're not going to hit proofs near as hard as what they do in this book right here, okay? You got a question? Okay. All right. So postulates is a word that you need to know. Theorems are a word that you need to know, or is a word that you need to know. And we've already talked about definitions. We even had the first three words, point, line, and plane. Did we have a definition for them? No, because they were what? Undefined terms, okay? So the first three terms that we learned in here were actually undefined, didn't even have a definition. But then we learned some definitions, and then today we're going to learn some postulates, and eventually we're going to learn some things called theorems. Theorems can be proven, all right? But postulates don't need any proof. They really can't be proven. They're just accepted fact. Ben? No, that's fine. You can just listen. Okay, if you want to write it down, feel free, but you don't have to. And if you want to read the rest of this, it goes on and on about stuff. But what I want you to do is look at page 12, and I actually have that image right here. So let's go to page 12, and you should see this. So what we're going to do, I probably won't do a whole lot of writing, maybe a little bit, but I'm just going to put this right here on the screen so you can read it. Oops. Let's do this. Okay, now let's move it down. There we go. Oops. All right, any day. There we go. That's what I want. Okay, these things are called incidents, postulates, and I think they have, let's see, I wrote it down in my notes. Let me get my notes out. So an incident, if a point is incident with a line, okay, this is another definition. If a point is incident with a line, it falls on the line or it lies on the line, okay? So we say it falls on the line or it lies on the line. So that would be an incident. So here are some situations where you have points on a line, and these are our postulates. So let's write them down, okay? I've got them right in front of you, but I think it's important to write these down. All right, so the first one is called the expansion postulate. Again, these are things that are just accepted as fact. We can't prove them. It's just stuff that we just accept for fact. They're not really definitions. It's just statements that we have to agree that are true. Euclid came up with these probably. I don't really know much about Euclid at all, but he probably came up with these way back in the day, and we're still learning them today.
Why do we have to agree with it if it's not right?
It is a fact. It's a proven fact. Well, it's not, I shouldn't say it's a proven fact. It's just a fact that we accept. Okay, we just accept it as true. All right. So look at it. A line contains at least 2 points. Well, that makes sense, doesn't it? Because a line is made up of an infinite number of points. So there's got to be at least how many? 2 of them. All right. No matter how small you make a line, no matter how infinitesimally small you make a line, there's at least 2 points on it. If you only have 1 point, then it's just a what? Just a point, right? There's no line, okay? So you got to have at least 2 points that makes a line. Now, it says a plane contains at least 3 non-collinear points. So in order to have a plane, you've got to have 3. Now, why non-collinear? So for instance, if I had a flat surface, like this little tablet right here, everybody look up here. If you had a flat surface, in order to make a plane, this represents a plane. It's not a plane itself, because a plane keeps doing what? It keeps going what? On forever and ever. But this represents a plane. If I had 3 collinear points, then watch. Boom, boom, boom. That would just make up a line. It wouldn't necessarily make up a plane. You can have a line and not have a plane, okay? But in order to make a plane, you have 3 points that don't all 3 line up on the same line. So for instance, like right here. If I can get mine. Oh, there it is. So look at these 3 points right here. You could have A and B. They're 2 points. Does just 2 points make up a plane? No. You must have another point that does not lie on that line right there. So if I have A, B, and C is not part of AB, then those 3 points make up a plane. We just accept it. Now space. Space is like everything. Everything in this room is considered space. Even if the point's on the floor, on the wall, on the ceiling, everything in here is space. So you must have 4 non-coplanars. So they can't all be on the same. You can't have 4, like on this wall right here. 1, 2, 3, 4. You can't have 4 points just on this wall. But if I had a 4th point over here, then that would be considered space. All right. We're not going to really talk about that very much. But the first 2 are pretty important, I think. So let's keep that in mind. All right. Do you see point D? D is not coplanar with this. So if I had A, B, C, and D, that would be considered space or everything. All right. All right. Let's talk about the next one, the line postulate. And by the way, do you see that P? What do you think that P stands for? These are what? Incident what? Postulates, right? So we name them. Now, there's no way in the world I'm going to expect you to know the numbers of these postulates, but they are numbered, all right? To tell you the truth, Euclid he might have numbered them, I don't even know. But different books number them different ways. So if I teach out of this book, I might say postulate 1.3.1, all right? But why do you think they put 1.3? Take a wild guess. Because what section are we on? That's right, we're on section 1.3. Do they always put these postulates on section 1.3 on every single geometry book? No, of course not. Every book is different. So this book labels it postulate 1.3.1. Why did they name this one 0.1? It's first one, exactly right. You got it, okay? Does that make sense? All right, let's take a look at the next one. This is called the line. Oh, we're running out of time. Let's go through it quickly. The line postulate. Any 2 points in space lie exactly in one line. Look, I have a point here, I have a point here. You could always connect those points and make a what? A line. Any 2 points anywhere, you could always connect and make a line. That's what that says. The flat plane postulate. It's in the book. It's in the book. You got it right in front of you. Okay? I said I took this right from the book. Okay, the flat plane postulate. If 2 points lie in a plane, then the line containing those 2 points lie in the same plane. So if you have 2 points in a plane, which means a line is in the plane, then that means the line is in the plane. That's basically what it's saying. All right? These are just, you understand, these are just kind of like common sense kind of things. 2 more and we'll be finished. Okay, bell's about to ring in about 2 minutes, so we'll be good. The line intersection postulate says what? If 2 lines intersect, they intersect at 1 point. We've kind of already talked about that before, but now it's official. Okay, now it's a postulate. 2 lines intersect at 1 point. That's basically what it says. Okay, if you have 2 lines and they intersect each other, they intersect in exactly 1 point, which means they don't intersect in any more or any less. Exactly 1 point. It's not like this line can come and curve around and intersect again. You with me? Or it wouldn't be a line, right? Now, we do have things that are not lines later on, like in maybe Algebra 2, you'll learn that you do have something that comes around and intersects a line at 2 places, but it wouldn't be a line, though, okay? The last one is this one, the plane intersection. So if I have 2 planes, if I had 2 sheets of paper and I put them next to each other, or I take this wall, we already talked about this earlier when we did these homework assignments. You take this wall, you take that floor, how does it intersect? This wall right here and the floor, what do they make when they intersect each other? They make a what? A line. And that's basically what this postulate says, okay? That's all it says. You see this plane P and Q? If they intersect each other, that point of, or that intersection, it's not a point of intersection, it's a line of intersection, isn't it? Remember, the planes keep on going, even though it doesn't look like it, the planes technically keep on going, and so, of course, that line is going to do what? It's going to keep on going. You with me? Yeah, that's not so hard, is it? Again, it's kind of like just common sense geometry stuff, okay? Nothing super weird about it. All right, let's do a little homework on this stuff, and let me change colors. Let me change this to that. Okay, so here's your homework. It's going to be, homework. It's going to be section 1-3. It's going to be pages 13 to 14. And it's going to be very similar to what you did before. You're just going to answer questions about definitions. They'll put some pictures on there. You talk about it. They may ask you to draw some pictures. So it's numbers 4 to 29. Okay, and we'll do all of them. Odds and evens. So that's your homework, okay? Pages 13 to 14. Make sure you put that at the top of your paper with your first and last name. And then all you got to do is just try, okay? Just got to try them. Once you do an odd one, look in the back to see if you're on the right track, okay? If you're doing it the right way. See, I told you today's lesson would be pretty quick and easy, right? All right, that's it.